The ultimate presentation of this workshop is AI and virtual reality, an integration for neurological healthcare. Does it mean to say that it can't be applied to the more generic case? But MindMaze is at the moment focusing on neurological healthcare. Some of the case examples I will be using is with stroke. And I take a particular perspective as the Chief Artificial Intelligence Officer of MindMaze from a cybernetics perspective, which is somewhat of an unusual word. We'll come back to it. But it's quite different from the bottom-up concept of AI. It's more of a top-down perspective, looking for feedback loops, control loops, which are particularly relevant in the healthcare perspective. This is going to come out in the presentation, I trust. Okay, so first of all, let's define the problem that healthcare has and why AI and virtual reality has an opportunity to be applied here. So the first point is that there is a limited number of healthcare professionals. Per capita in the UK, it's going down at the moment. And that's not necessarily unusual. Even though the need for healthcare is increasing. As longevity increases, neurological healthcare, damage to the central nervous system, actually increases. So there is a crisis developing in the industry. And the costs of some of the technology that we are using to diagnose and provide therapy in these neurological healthcare is not becoming that much cheaper faster. And so the cost to provide care is a significant issue. So we really need to address these issues, not least in the industrialized, developed world, but also to extend that access to the newly industrializing, the less developed world. I'm actually talking at a United Nations Sustainability Development Goals Conference on the 25th in Geneva. MindMaze is based out of Lausanne in Switzerland. So there's a bunch of really important issues here defining the problem and the solution, and it often comes out that AI is a solution before defining the problem. So I definitely defined the problem first. The solution for many folk is the use of AI integrated with virtual reality, particularly in the therapy side of things. And I tend to look, when I look at a solution's benefits, for 4 factors. Productivity. We should be using AI to augment people or perhaps replace people so that productivity increases. The quality of the diagnosis, let us say, should improve at very least over human activity. Otherwise, the business case, the use case is deteriorated. The opportunity for AI is to personalize, to make healthcare less of a robotic opportunity, which sounds weird. But the idea is that with AI, there should be time for particular patient individuality to be recognized, which in the traditional model, unfortunately, is often lost because the time pressure for healthcare is so oppressive. There should be the opportunity to discover new, or let us say, patterns which maybe can be lost in the confusion of time in a human case. So, for example, an individual may have stroke, but also may have depression, may have dementia, and recognizing the interplay for particular individuals is a real issue for many human diagnosis systems. So the goal is to provide a solution with AI and virtual reality to have a massive impact across these use cases. And it's sufficient enough to refer to it, this paradigm shift, as to parallel the industry 4.0 and 5.0 concepts, to say it's a healthcare 5.0, a major paradigm shift. And having said that there's great opportunity here, there are also significant risks. And I will touch on those because the solution must be made in the context of the risks and not just the opportunities. So we're going to very quickly look at some healthcare opportunity, the size and magnitude of it as indicated by some independent consulting, management consulting groups. I tend to use this PwC graphic a lot in my presentations. It's a cumulative growth curve in terms of the dollar opportunity, actually a pound GBP opportunity. The number, you probably won't be able to see it unless you're very close to some of the screens, but it's 15.7, let me make sure I just, trillion pounds by 2030, which is what, some 11 years ago? And it's very easy to get lost in that number, 15.7 trillion pounds, that AI will impact cumulative over the years. That's twice the amount of gold that has ever been mined in human history will occur because of AI. And this is not just PwC, there are many commentators, and we're tracking on that growth. Healthcare is recognized actually as the first or second major use case contributor. But that's AI. I've also mentioned about VR. There's a bunch of VR companies in the healthcare market space. MindMotion is indicated by one of them, thankfully, by Citrus Bits. But in terms of this major portion by sector, mostly VR is in the entertainment industry. But the second biggest application is in healthcare. So there's a real resonance of opportunity here. I mentioned I was going to talk about risks and recognizing my time as well. This is I think, a World Economic Forum graphic, and it shows, it's very difficult to see with the shading here, the benefits versus the negative consequences. So the greatest benefits in terms of emerging technology is on the right of this diagram. So you have biotechnology, artificial intelligence, and robotics. And many of you will recognize the hype, which is often talked about in AI in terms of existential risk and bias and what have you. So it's considered a very risky technology, but on the positive benefits which are applied, actually that's on the right, and the negative consequences, the risk is on the vertical scaling. It's also the same. So the biggest opportunity, but the biggest risks. And that applies actually to things that are also relevant in the healthcare side, whether that be neurotechnology or proliferation of the ubiquitous IoT sensors, which collect behavioral analysis, that collect biosignal data. So we have to recognize the opportunity when we're building solutions, but recognize the risks. Make sure we mitigate those from the design principles in the first case. Okay, I'm going to talk a little bit now about why I think it's worth seeing the paradigm shift benefit and why I refer to it, and others have started to refer to this shift as Healthcare 5.0. So let's just recognize some of the points I've mentioned earlier. There is an ongoing global healthcare crisis, costs increasing, access to human health practitioners is actually being stable. It takes 15 years to train a clinician, a doctor. So even if there was the money to invest, it would take a significant lag to make a major impact with traditional human technology or human beings. A whole bunch of stuff here. Rampant corruption in many countries of the world. We need systems with transparency. The lack of patient engagement. Patients are being treated in a less personalized way for the sake of productivity. That's a major issue. The fact that we haven't fully gone into the digital transformation of the healthcare industries, helping to build large data lakes of patient data that we can mine effectively for the better utilization of those services. And there are security and privacy issues there. So all of these contending opportunities and risks are causing kind of a stalemate situation in terms of building better healthcare. So, if you look back in the history of the paradigm shifts in the provision of healthcare, you'll see that it's gone through 3, 4, 5. The last one is the artificial intelligence, personalization, previously digitalization, automation, industrialization, and basic production. So you can, I believe these slides will be made available. I don't intend to go through each and every bullet point here. The point I'm making is that there are paradigm shifts, not just in industry, but in terms of specific applications, such as in healthcare. And that personalization is driven by 3 factors. The quality of healthcare being provided, the responsiveness, the timely responsiveness of healthcare being provided, people not having to wait 3 to 6 months for hip replacements, et cetera, and the fairness, so the access to this service, whether that be because of the economic circumstances of individuals, or whether they live in well-developed or less developed countries. So there's a whole bunch of issues there driving 5.0. And one of the points here, and I'm starting to refer to some of the concepts which I believe are cybernetic in nature, is this loop and continuous learning opportunity. So we're in a situation where we can use AI for diagnostic, prediction, and classification. And we are in a position where we can use AI to make appropriate interventions, early interventions, personalized to the individual. But we wish to build this in a holistic model where the data is being used by all the components in the delivery of the individual processes, such that we can affect that productivity benefit and learn from that. And I'm going to come back to a reinterpretation of this slide later on in my presentation, which relates to a patent pending process that I have written for MindMaze in this respect. So let's look, since I've been talking about MindMaze, at some of the ideas that we have products which are relevant in stroke, which have been FDA approved, and I'm going to go into a little bit of those next. So let's talk about MindMotion, which is a product which we are bringing to market this year, and indeed have already started the selling process through Germany and in the UK and the USA and other countries of the world. And this is a neuro rehabilitation program whereby we are specifically focusing on stroke patients who have had an incident. They have gone through the so-called acute phase, which is basically treating if the stroke was due to a hemorrhage, which is bleeding in the brain, which is potentially a fatal condition, and that has to be interacted with in the first minutes. We're not talking hours of that condition. The majority of stroke cases, incidents, are, however, ischemic stroke, where blood is not so much leaking from a rupture, but has a blockage and oxygenation is being denied to the neural tissue. And after a few minutes, again, that neural tissue will die. And individuals start to have characteristic conditions in terms of loss of mobility, in terms of slurring of speech, etc., etc. And again, action has to be taken as soon as possible. And there's a period of time when an individual is recognized, brought into treatment of a few days to prevent further damage. That's a few days in terms of treatment, in terms of therapy. Then there's the subacute phase, when the brain, in a mysterious process that we do not fully understand, is engaged in neural plasticity, whereby there is a process, an organic process, where the brain attempts to transfer functionality from one part of the brain to another part of the brain. And individuals may start to see small improvements. But unfortunately, that neuroplasticity phase is quite short, this phase that we call the subacute. And what we really need to do is to try to interact and treat the patient in the most effective way possible, as early as possible in that subacute phase. Because if we do so, we will have a faster recovery. Now, as far as my best clinician colleagues advise me, we are in a situation where even with the best therapy, it's difficult to improve the end state. That means to say we can predict with a degree of accuracy, knowing the algorithm is called PREP2, and it basically uses things like shoulder, arm, and finger extension. So if you calculate the metric of the damage from those, together with information from the National Institute of Health, together with some magnetic stimulation to see if circuitry, so to speak, in the neurocortical column has been damaged, we know that this patient's going to get to this end state. What we don't know is that if that end state is going to be achieved in 2 years or in 3 months. Now, because of the cost of therapy, we want to do it as soon as possible, and the patient wants to recover as soon as possible. So what we have to try to do is to do the most effective therapy as soon as possible, and to do so with the most increased dosage of therapy that the individual can sustain. Now, with limited clinicians available, with limited, let us say, expertise, because not everybody is an expert clinician or therapist, that often is not occurring. Individuals get physical therapy even in the subacute phase for an hour, for 1 or 2 days in the week. And then having gone from the subacute phase into the chronic phase, which is like week 2 or 3, going onwards to 6 months or more, then they're outpatients typically, either coming into a clinic once or twice a week for 1 hour or 2 hours, or doing exercises at home, sometimes with therapists in attendance, sometimes not. And that is not the best way to increase the tolerance of dosage of therapy. It's not pharmacological typically, it's therapy, specific, focused, targeted physical therapy for the condition of the individual to exercise. If they have problems with movement in the elbow, then have elbow-focused therapy. If it's the shoulder not being able to raise beyond a certain level, then find therapeutic exercises which focus on that motor deficiency. I trust I make myself clear. And the way that we believe that we can do that is using AI to diagnose and to do the prognosis, but also to advocate the best therapy for the individual, and to do that, to advise in the subacute phase the therapists to do the right things to help build up the quality of that therapist, to do the most effective recommendations. But in the chronic phase, when the users are at home, to have at-home AI-enabled, gamified, virtual reality, to be able to use motion detection systems for the kinematics to determine the improvement or the non-improvement, and to pivot the therapy to keep the individual being occupied with the correct therapy. That's what we're trying to do at MindMaze, and indeed we are doing so. We have the MindMotion Pro platform, which is typically applied in that subacute phase, and the MindMotion Go in the chronic phase at home. And we're using AI, we're using virtual reality and gamification games to be able, which are targeted to specific motor deficits. The companion is an interface to the system that is on a tablet, and that builds the family of the MindMotion platform. This is a video, unfortunately it's not working, but it's a nice video in the sense that it tells you what I've just told you. But we don't need to go and spend time on that because we've only got 10 minutes. This particular diagram, I'm afraid it's not coming through with perfect clarity. I hope you can see it on the screens. I hope you'll be able to access it. But we've sketched out the journey of the therapist for specific individuals. And what, unfortunately, I think it'd be very difficult for you to read is we envision the training content in terms of being continuously evaluated. Not just in terms of the kinematic improvement, but the emotional journey of the individual. If our intent is to engage the patient in such a way that they are excited and motivated and happy with the therapy, and are not depressed, who are not in pain, who are not fatigued by the therapy, then if that's being done at home without a human in attendance, we need our AI system to have the affective computing capable to say, I'll say it in English, I think my patient is fatigued. Because he's dropping his head, I can detect that by kinematic motion. Or because she has galvanic skin resistance, which suggests fatigue, or whether there's a facial recognition, or maybe eye tracking, which suggests distraction. So all of these affective computing, multiple modality, I call it artificial empathic intelligence, that we can engage with that, and then with a virtual assistant who's playing the therapist in attendance to suggest comments like, "Are you tired, Mr. Jones? Shall we take a 5-minute break?" Because if we can engage with the patient at that empathic level, the opportunity of keeping them engaged and constant in terms of their commitment to use the system may be the difference between 6 months of therapy and 3 months of therapy. And that 3 months of therapy is very valuable to the patient to recover as quickly as possible, their normative behavior, but it's also effective in reducing the cost of providing that therapy. And this goes a little bit further. We'll skip past that. So here is a gamification scenario. So there's an immersive environment. We call it the video arcade. And we have a specific game. This is called the Whack-A-Mole Challenge. You'll be familiar with it, some of you maybe, where we overwhelm a player with actions that they need to take in a specific time frame. The actual action is to hit the mole on the head, and then another mole will pop up, and then you hit the mole on the head. So you're making movements like this. Now, those movements may be very difficult. They may be impaired because of the elbow and the shoulder movement. The patient may be moving their torso so that they can move that. So we want to be able to sense that movement and say, oh, that's not normative. Can you sit back in your chair and extend your arm for that, to advise the movement, the kinematic movement, which is relevant to the impairment improvement. So we define the strategy, we design a game to do the right therapy. Here we actually monitor the movement of the upper limb, in the case example I gave, and we are monitoring the movement of the elbow, the shoulder, the wrist, and we build a workspace. And that workspace, if the therapy is going to be achieving the goals of improving the motor deficit, is going to increase in time. And so we're not only monitoring the kinematic data, but we're also monitoring the game performance and making inference as to what we now call a level progression evaluation or recommendation engine, where we are saying, okay, we're now ready to increase the level of the game, to speed up the number of moles being whacked, or we need to change the game because we've achieved our elbow improvement, but we now need to focus on more shoulder-related gamification. So here's can we check this? So we have developed kinematic detection motion detection. We originally started out using Microsoft Kinect, which many of you will be familiar with. Now, Microsoft went through a period of time where they retired that product for about a year and a half. And within MindMaze, we bought up 2,000 of these systems as a stock so that we would have the ability to fulfill that. And Microsoft didn't provide a replacement until about 2 or 3 months ago. And it's still on back order for the Microsoft Kinect Azure DK development kit. So what we did to make sure that we're not, how can I say, snookered, to use an expression, is to build our own motion connection visual system. And if we just tick on this video again, please, I'll just point out the, how can I say, the accuracy of the human to the movement. And it's the actuators in the robotic sense. It's the joints that we're really seeing and looking for and deriving algorithms to determine the workspace. Okay, we do other things in MindMaze. We take, not just provide gamification, we can provide that through a traditional virtual reality headset. On the left, you can see a diagram, an image where we're also doing EEG. On the right, what we're doing is actually using EMG sensors to detect the motion of facial muscles, because by doing that, we're able to do things like detect that this gentleman over here, who's on the 8th floor of our office, is actually snarling in road rage, whereas this lady is pleasurably experiencing the driving experience. Now, actually, that kind of emotional affective computing is what we're after. And we can do that with visual interfaces. So we don't have to have a mask. We can actually have a camera to detect that affective computing. Okay. Yeah, I really am coming up for time. This is an example of the Mind Mask with integrated with EEG, so we're able to detect many of the affective cognitive states of the individual. I'm just going to go quickly through into the cybernetic concept, which I promised we would do. Cybernetics is a concept that was developed really in the sort of mid-part of the last century and was prior to artificial intelligence. And basically the concept, unfortunately the diagram, some of the words are off on the left here, was basically the scientific study of control and communication in man and machine. And it was a top-down perspective. AI is a bottom-up perspective where we seek to develop cognitive functionality equivalent in an artificial way, but from an emergent a bottom-up exercise. And it's a transdisciplinary concept because it includes control theory, information theory, optimization, general systems research. And that's really useful in the healthcare environment. On the image on the left there, you see a pacemaker. Actually, I'm not sure whether this was the pacemaker of a specific individual, but let me just mention Pope Benedict, the Pope prior to the current one, was a cyborg to the context that he had a pacemaker. That was a cybernetic device that took the input about what signals were going on in the heartbeat and basically augmented that control process. But from such small beginnings, we're moving into BMIs, where with EEG and other sensors, we are detecting intent. And almost day by day, there are new papers and articles about the extent to which BMI is really helping us. And in, I think it was at the, not the Olympic Games, it was at the World Cup in Brazil about 6 years ago, there's the Walk Again project, whereby a brain-machine interface was used for an exoskeleton to help paraplegics walk. And what was really interesting, by the way, from that Walk Again project is something that wasn't expected occurred, which was people with the BMI and with the physical exercise of walking were actually recovering spinal connectivity. The power of the mind in being asked to generate a signal to drive an exoskeleton was causing neural morphogenesis, a recreation of neural connectivity. It's a really interesting corollary of that research. So what's going on in a typical feedback cybernetic process is there is an input desired. So let's move your arm up. Now there's a controller, which is a digital model in a certain sense, in the modern sense, which suggests that this model can be done with this kind of action. But then you apply that signal to the actual control plant, the arm, and you will or you will not get the actual result that you expect. So dependent on that, you feed back the process. It's this loop, this continuous loop, which is the cybernetic principle. And we measure and detect a variety of input data. We estimate, do a diagnosis of the health state. We go through therapy and prognosis and guidance, and then we go back and we're constantly collecting and managing that process. So it is a cybernetic loop. So what we've done in MindMaze is create a holistic model of how this all works. So we're basically looking at patient data, developing a database. We have multiple therapies that we can use to attain good outcomes ideally. Some therapies don't give good outcomes. They only give fair or poor results. We want to be able to collect this data so we can do data mining. And then once we've done data mining, we can look for new neural network models of therapies in a digital model and keep that in a feedback process. I recognize that I'm very short on time. And so this cybernetic healthcare is taking in genomic data, medical knowledge, data from sensors and personal models, and through cybernetics is helping to keep that as a constant flow and feedback process. So just ending up with a few quotes here, the CEO of Google basically says that AI, he expects, is to reshape healthcare. They have to work through some of the regulations for privacy and the like. But he sees that it's one of the biggest areas that AI will impact in the next 10 or 20 years. And Tony Parisi of Unity Technologies, on the VR side, again, sees that the impact on education, and therapy is a kind of education. We are educating stroke victims to recover their functionality through the use of VR. So with that, thank you very much. I do apologize for being 2 minutes over time. Bear with me for that. If you have any questions, I'll be happy to take them either now or privately. Thank you very much.